Hi, we are second-year students from School of Chemical Engineering, University Science Malaysia. We are from Group 4. Today, we are going to present about the internal energy. History of internal energy. James Joule studied the relationship between heat, work, and temperature. He observed that friction in a liquid, such as caused by its agitation with work by a paddle wheel, caused an increase in its temperature, which he described as producing a quantity of heat. Expressed in modern units, he found that 4,186 joules of energy were needed to raise the temperature of 1 kilogram of water by 1 degree Celsius. Definition of internal energy. Internal energy is defined as the energy associated with the random and disorder motion of molecules. Higher temperature have more internal energy. The substance do not contain heat, instead it contains internal energy. The addition of heat to a substance increases molecular motion, and thus causes an increase in the internal energy of the substance. Heat is a transfer of internal energy from a high temperature region to a lower temperature region. At low temperature, the particles move slower, while at high temperature, the particles moves faster. Next, theory of internal energy. When heat is added or work is done on a substance, its internal energy is increased. The internal energy of a system is the sum of all forms of microscopic energies. Internal energy refers to the energy stored in the random motion of the molecules. Equation of internal energy is U equals to EK plus EP. The unit is in joule. U is internal energy, EK is kinetic energy, and EP is potential energy. Does a glass of water sitting on a table have internal energy? The answer is yes. There is microscopic kinetic energy, which is a part of internal energy. And there is a molecular attractive forces which are associated with potential energy. Let's learn about kinetic and potential energy. Kinetic energy is the energy that a moving object has due to its motion. The formula is EK equals to 1 over 2 mv square. Potential energy is energy stored in an object due to its position. The formula is EP equals to mgh. M is mass, v is velocity, g is gravitational acceleration, and h is height. There are three forms of kinetic energy. First is translational. Second is rotational. Third is vibrational. Let's move on to example of calculation using MATLAB. There are two balls, ball 1 and ball 2. For ball 1, it has 100 joule of kinetic energy and 600 joule of potential energy. What is the total internal energy in ball 1? For ball 2, it has 500 joule of kinetic energy. What is the potential energy, if the total internal energy is 700 joule? Now let's see the solutions. For ball 1, the EK is 100 joule, EP is 600 joule. By using the formula, U equals to EK plus EP, which is 100 joule plus 600 joule, the internal energy is 700 joule. For ball 2, the EK is 500 joule, U is 700 joule. By using the formula EP equals to U plus EK, which is 700 joule minus 500 joule, we get the potential energy as 200 joule. This is how we plot the graph using MATLAB. The bar graph shows energy versus ball. For ball 1, EK equals 100 joule, EP equals 600 joule, internal energy equals 700 joule. For ball 2, EK equals 500 joule, EP equals 200 joule, internal energy equals 700 joule. The next part is the references. These are the references that we used to make this video. These are the group members of Group 4. Finally, we have reached the end of the video of the internal energy. Thanks for watching.